Okay, so to pick up where we had left off, we have our, whoops, oh, now I'm getting this all messed up here. We have our board that we're trying to lay out, and I have a cat again trying to help me. Um, and we put all the components down, and now, there is probably a suggested layout for this, but I'm just going to go ahead and de-rat's nest this just as best as I can here. And now, one thing I did here, I'll put in, talk about it, is that, I put in, and these are just simply jumper connectors, where, they're not necessarily the best kind of connectors, but often, again, when you're doing with a board, is that you're going to have some kind of connector for the board to get power to the board, or some kind of input or output connector to it. Uh, and even here for the potentiometer, I'm looking at this as that you wouldn't actually necessarily have the potentiometer physically connected here, is that it would be kind of on the outside of the box, because it's going to be a little knob that you would turn, and then you would use that knob to turn it, and so the potentiometer would then be connected up here, and there's different kinds of mountings like panel mounts and things like that where you can use blade connectors, things of that nature. And sometimes, of course, they are mounted directly on the board. Uh, if you're looking at a cell phone charger, for instance, with a USB connector on it, those USB connectors are mounted directly on the boards, but then the board is also then mounted directly against the case. And so there's lots of different ways of mounting things. So, but for now, we are kind of using a lot of times connectors to get our inputs and outputs mounted together here. Okay, so let us first here, I'm still on this here on the place component area. So if you're coming back here just to kind of remember where, if you're just reopening here, I do place component manually. And again, the reason I keep this one open is it's much easier to select my components and then move them around. Now, sometimes it can be helpful to look back at your diagram, because that can sometimes help you figure out maybe how to orient some of your pieces. I often just try and start playing around as well with some of them. So I do have that there's some of these diodes that are connected to these pins. So I'm just going to go ahead and move this diode here. And then we can see there's another one that's connected there. And so I'm going to just rotate this one. And I said I would mention about the grid, and so why don't I do that right now? You'll notice that there's no actual grid dots, and that's because the grid is so fine that if it were to draw all of the grid dots, it would just be a solid screen of dots, and you would actually not see anything. But if you go down here, because at the bottom of the screen, so right down here, it shows the current mouse coordinates. And if you can see here, I can move, and if I'm very careful with my mouse, it's very hard to do with a mouse here at this point, to move just an individual unit. I'd have to be zoomed in more. But, that gives us complete freedom. So there's basically no snapping to a grid point at this point here. Um, so, and then seeing where this one is, I might put this capacitor right here. And then this capacitor might be here, because again, we're trying to, they call it de-rat's nesting, and I don't know if you guys ever played this when you were kids or not, but I think of it as like the kind of pick up sticks kind of thing, where I'm trying to make it so that all of the sticks aren't arranged here. And so I've got this here on the output here, and then let's see here. move some of these things around. And as you move them around, sometimes the actual connections get moved around too because of the way they're being wired up. Okay, so that looks decently D-rats nested. I'm not saying that this is the perfect one, but it's looks pretty decent. So you can still see there's some things that are crossing over each other, some things that are still not connected together. Now, again, what we need to notice here is where things are being drilled through and where things are not being drilled through. So we have drill holes going right here and right here. I can tell that because there are circles, but then also because of the part that I used, and if you zoom in here, this green here, let me actually try and do it with some of the layers here. If I turn off these and turn trying to find the one for the that's the legends. Well, there is a way, if I could remember. To show that those are drill holes, but I cannot remember where it is. Oh, is it here? No. Well, I'm spending a lot of time trying to show you something that isn't quite necessary. I'll show you a different way that you can determine that these are things that both have a top and a bottom. So, but the green here, we can see also has a top and a bottom, or does not. The easiest way to do it is by going to connect and route. So I went here to route, connect. Okay. Then I'm going to go to bottom. And you can see here, there's only these things now that are in yellow. These are the only things that have yellow etch on the bottom. So that's how I know that these are through-hole components, because they both have a top and a bottom associated with them. So those components are going to be going through the board. And typically, again, we solder through-hole components on the bottom. Now, the surface mount components, we can see these pads stay green the entire time. And the pads for surface mounts tend to be rectangular or square-shaped. All right, so let's go ahead and do my route. Now, we went with 16 mils because remember we said that that's going to actually be able to withstand 1 amp of current. And you can see here that that actually is not that big of a trace, as far as, I mean, it's a pretty small trace when you look at the size of some of these pads. And so I'm going to go ahead and do my first connection. And notice how it kind of automatically, I was kind of running up against here, but then when I came down here, it's like, well, wait a minute, that makes the most sense. Now, that's the program trying to, again, do what it thinks makes the most sense for your route. You can always, and I'm going to left click here and be a little silly. If you left click, you can force the trace to go however you want it to go, which is a little bit silly. And then I love this one here. You can do oops to back it up, or the easiest way is to hit cancel. And then I'm going to restart here. And then I'm just going to go ahead and connect some of these up. Now notice it's always going to route it to the middle of that pin. And I'm just doing some what I would consider are some obvious easy routes here. I'm not doing anything really funky as far as like going up and around. I'm just doing some what I would consider are some obvious connections. And actually, I already made a mistake here. I need to delete these because I went ahead and connected what I said were traces that need to be connected from the bottom because they're through-hole components, and I connected them on the surface. So let me go back and fix those by deleting those. Just getting ahead of myself. Technically, you could connect them on the top as long as the holes were plated, through-hole plated. But if the holes are not plated, which most holes would be plated for you, but they're not always plated. So let me just start my routing again and not do those right away. Route connect. Okay, so I'm connecting up there. This one's connecting here. Okay, now we're going to start getting into some more unusual things. So this one connects up to here. That's something that is on the bottom. Whoops. I hit done. I didn't want to hit done. I've got a cat again. I know I mentioned it before, but he is stepping on my keyboard and making life enjoyable. What did I just do here? Okay, I just did undo because I don't know what I did, but I did something and I hid all of those route lines. Okay, so I'm back to the routing and connecting here. Now there are some here, like, okay, well this one I could connect by just going through here like this. Okay, but now there's this one that needs to get connected over to here, and this one that needs to get connected all the way over to here, and this one connected here, because the ones that are remaining really are the ones that are connected up to my pins that we said that are through-hole pins that we want to connect up on the bottom. So I'm going to show you here. I'm going to start with this one because this one's the easiest one here. I'm going to left click and start here. So I'm on the top. So now I'm just going to double click, and now it puts a via there. Now your via is probably going to be a lot smaller. I changed the via on my system at home to be much larger, but yours is probably going to look much smaller. Doesn't matter the size, it's there. And then I'm connecting it on the bottom. Now, if I start another connection now, notice that I'm on the bottom, and then if I double click, I'm going to go back to the top. So if I wanted to start back on the top, I'd have to select top here, and then the alternate I'd want to select is bottom. So, oops, if I were to start from here, double click, and go like that. And now there's a couple ways we could go about connecting these pins up. I could stay, well, I'm going to stay on the ground. I could stay on the ground and just connect straight down here to this pin. Or I could come out here, lay down another via, and come back up to the top and place it like that, which is the one I'm going to do here. And now I've got to get this component all the way over to here. And so I'm going to start on the surface, or actually, why is it doing that? I'll do the oops there because it started on the surface. My top and bottoms are doing weird things here. So starting on the surface, I'm going to come over here. Now I clearly can't just cross this here. But what I can do is I can do a double click, and now I'm on the bottom layer, and I can lay this trace down here, just like so. And there's no issue with that trace. Now I wouldn't want to put a via here, because that via, if I try to put a via right there, you see it's going to interfere with that trace that I just did there. So I'm going to not put the via there. And I'm going to go down, and maybe I will first connect into this hole down here, because it's a bottom connection anyway. I'll say done with that. Then I will connect again. I'm on the bottom here. So I'm going to go ahead and start Netch, and I'm just going to go here. Actually, I'm going to not start it there. I'm going to start it right here. Double click to put a via in, and then connect it up there. Now I have one blue line left to connect. So I'm on the top, so it should put this on the top, yep. And now I need to connect it to that pin, but I got to do it on the bottom anyway. So I may as well put a via, drop a via here, and connect it up this way. And now I've got my board. Now this is definitely what's called a two-layer board, because I have both a top and a bottom associated with this board. There is no way for me to work on this board as far as there's no way for me to etch this board using one side. Now, that's not to say it would have been impossible for us to route this board using only one layer. I just went for easy using two different layers. And so we would go ahead and say done. And then if I were to want to export the Gerber file, again, I can do top and bottom, create my artwork. It's going to say completed with warns, or says photo plot outline rectangular, not using draw extents. DRC out of date on this layout. So I forgot to do a DRC update. It still generated the artwork for me, but what I forgot to do was make sure that all of my design rules were being checked. So if I go to check and do DRC update, I do and get that nice and green now. And if I were to re-export my Gerber files, I get successfully completed with no errors this time, or warnings. I should say there wasn't an error, there was just a warning. And then the NC drill file, remember, we do the auto to select, enhanced Excelon format, and then we do drill. And we've done our drill file. And so we have all the information we need to now etch a board for this circuit. And again, this circuit, this is the power supply. Is this? No, this isn't power supply. This is the power supply here, and this is really the output. So what you would be doing is you'd be connecting an LED up to this connector here, and this is ground. So you'd put the one leg of the LED here, the other leg of the LED here, and then you'd get the LED, and then you'd have a potentiometer connected up here, and then you could turn the knob and have the LED be brighter or dimmer, because that's what the circuit does. So now, a couple things I should point out in this. This is a terrible layout. The reason it's a terrible layout is this actually violates all sorts of IPC standards. Some of the standards it's violating are having signal pass crossing. So what we mean by that is notice here we have this trace here, and it's a signal trace in the sense I didn't label all these traces well, but it's not my power and it's not my ground. So there's some kind of signal going on this, and I've run it directly over these other signals as well. And that's really kind of a no-no. You really want to avoid doing that, because what can happen here is we've actually formed a capacitor, because the simplest form of a capacitor is that you have two conducting plates separated by an insulator. Well, if you're thinking about this circuit board, you have a top piece of copper and a bottom piece of copper. And so right here at this kind of crossover point, there's a piece of copper that's on the top and a piece of copper that's on the bottom, and it's separated by an insulator. So we've actually formed a capacitor here. And so if we formed a capacitor here, then what can actually happen is some of the signal that's on this particular green line here could end up on this yellow line and vice versa. Now, because of this particular circuit and the frequency we're operating at, it's irrelevant. It's not a big deal. Nothing's going to happen. But especially if you were talking about high frequency things like cell phones, things like that, that would be probably a very bad thing to have happen in your circuit layout, having two different signals crossing over each other. All right. Now, one other thing here that you'll often see in circuit designs is that you'll see that they'll actually have, and we'll look at this in another example here. We've even talked about power planes and everything else like that, but sometimes on even boards that are only two layers like this, what they'll do is you'll see on one side of the board, they'll have this big, huge thing of copper that is, just still sitting there. But then it's connected up to stuff. Like it's connected up to ground, for instance. And let me show you what I mean here. So what you can do here, and I'd encourage you to do this as well, is we're going to go our active subclass. Well, first off, make sure your active subclass is etch, and then we're going to go for the bottom. And then we're going to go to shape add here. And so etch bottom, and then it says assign net name, and it says dummy net to begin with. But if I do these three dots, it pulls all of the nets, all of these traces that are available. And so I'm going to put 0 in for ground. And so I'm going to click OK, and then I'm going to start up here. And I'm going to start kind of tracing a little bit of I must have had my mouse go up. It's because the grid is so fine. And I'm going to start tracing some things here out. And so now what I've done is I've created this huge piece of copper now that is going to still remain on the board. So it wouldn't get etched out. And it's labeled 0, so it's ground. And what I can do, now you might say there's no need to do this, and technically you're correct, there's no need, but if I'm on the bottom, what I can do is I can actually throw some connections here from my ground, and sometimes they even will throw them in multiple connections to it. And it might seem weird why you do multiple connections to that. And then I'm going to say done. Now, these paths that are in here, when you generate your artwork, it's smart enough to know that, hey, I'm not actually going to etch out this space here. I'm going to just be etching, you know, this shape here. You know, it's not going to actually go in and etch these pieces out because you're just literally connecting in there. And this is something that is done for a couple reasons. One is that having a large amount of ground can help make sure that any kind of signal interference can get kind of routed to the ground plane. And then also it's often used for sometimes heat dissipation. And sometimes it's not even ground though that you would do for your heat dissipation. So let's see this VCC bar here. Let's do another one here, and let's put it on the top. And I'm going to just do a rectangle this time, and we're going to do etch on the top. And the net we're going to do is we're going to put it on VCC bar. And I'm just going to put one like this here. And then I'm going to connect up to that. A couple different ways here. So again, why would I do something like that? Well, now this most likely wouldn't be the case, but for some chips you need to have heat sinks. Well, instead of attaching physical heat sinks to the top of it, there's some tricks you can play, and you can actually just make your heat sink out of a piece of copper, depending on how much heat you have to dissipate. And so you could just literally have a piece of copper kind of left on the board, and that's where the heat is getting dissipated to, is that piece of copper. Now that most likely wouldn't be the case. You would need that for this power supply, but that's another thing you can do for it. So you can add in these things. Now, it's not necessary to do those things, but those are things that are done in designs quite frequently.